Hi all, and in this session, let's quickly revise Python using the chapter 1 of Sumita Arora class 12, the computer science textbook. And this class is basically a grammar class of English sort of, and here we'll basically discussing all the keywords and syntax and basic loops and everything that is covered in Python. So let's quickly start it. So let me introduce you a word called token. And what is token? A token is the smallest unit of a program that is meaningful to the compiler. So what do I mean by this is any sort of word that compiler has some meaning is called as a token. So like what are actually tokens in Python? So if we see here, we can see that we have keywords, identifiers, literals, operators, and punctuations, all the five as a tokens. So what are the keywords? Keywords are something which are native to the language, and we can say that this for, if, and print, all this inbuilt words in range, these all are kind of keywords. And what are identifiers? Identifiers are nothing but the names of the variables. So here we have a1 as the identifier, a as an identifier. So actually the compiler can make sense of all these things. So it can make sense of keywords because it is already taught to compiler what this for means and what this in means. So that is of keywords. Then comes the identifiers, which we kind of gave it. And the next part is literals. What is literals now? So literals is nothing but the numbers or words, strings that we give in our we have in our program. So next is operators. Which is addition operation or subtraction operation or anything of that sort. And the last we have punctuations. So let's quickly see what punctuations are here. Just like we have opening and closing parenthesis in other languages, we have here a semicolon in Python, which is used to kind of open a loop or declare a if statement which ends with semicolon. So these are the kind of words that is present in Python. So these all are known as tokens. And let's quickly go through the definitions of all of this. Keywords are the predefined words with a special meaning to the language or keywords are predefined words with a special meaning to the language, compiler or interpreter, whatever that is being used by the language. So that reserves few words for itself. So such words are known as keywords. And identifiers are nothing but the names given to variables, objects, classes, functions, lists, etc. And literals, what are literals? Literals are nothing but the values or constants that is present in your program. And literals in Python can be either string literals or what else we have? We have here numerical literals, Boolean literals, and special literal also is there in the Python, which is none. So let's quickly go through what is string literal. String is sequence of characters surrounded by quotes in Python. So we can have three ways of representing strings. One is like continue in the single line. If your string sizes fits into one line, then you can just simply represent with the double quotes. And if you want to make it into multiple lines, you just have to add a backslash to it. And using triple quote, you can avoid those things and you can write any number of lines you want. So after string literals, we have numerical literals, which are integers, decimal, octal, hexadecimal, and float point literals. And what is a literal actually? Literal is nothing but a constant or values which that variables can have. It's just like a different constants that we define throughout our program. And we have operators as well. See, all these are part of tokens that we are discussing in Python. So the next topic is operators, tokens that trigger some computation action. So this is the token that will trigger some computation action when applied to variables and other objects in the expressions. So obviously we are very familiar with arithmetic operations throughout our mathematics, and bitwise operators is something which is relevant to computer science, and all these shift operators are also frequently seen in computer science itself. Is simple logic operators, greater than, less than is also logic operators, and assignment is something again we'll see in all the programming languages. Membership operator is also specific to Python, and assignment operators are very frequently seen in programming. And after that, we have some punctuators which have single quotes, double quotes, triple quotes, and all, and comments, extend line, expressions, etc., which are present in Python. So after this, let's quickly go through the bare bones of a Python program. So how does it look? So a comment in Python is generally indicated using what is this hash, right? So, and after that we have statements, indentation, function calls, and expressions. So these are the statements, and here we have some indentations which are spaces, right? And here we have the functions. Print is a function, right? So, and here is a custom function that we have defined. Define cu is like time to say goodbye, right? So I think this is common in all the programming languages. So you have some comments, and you have some variable declarations, and you have some methods written here and there, and yeah, that's how the flow goes. And also I would like to mention one point here. There are two styles of coding. One is imperative, and other is declarative. And to mention what is imperative is like you give step-by-step instruction for a computer to do what all it has to do, and computer does it for you. And that sort of languages are C, C++, etc. And declarative languages, you just have a higher order function which will kind of do the things for you. So it's like if you want to book plane ticket. So in imperative style, what you have to do, you have to say that go to this particular website, open this particular page, and click on this button, and all this stuff, clear instructions for the program. And declarative programs, they have a function called book sort of thing, which will book for you whenever you invoke that function. That's how it works. And declarative programming style is followed in Python, and it is followed in JavaScript, etc. And it makes the code more readable, I can say. And the next part, we have variables and assignments. So what are variables? Variables are nothing but a label storage locations. So let's say we have a locker in bank or at any place. So here we have 4 lockers, and we can store something inside it, okay? And here we have number as 101, 102, 103, and 104 for these lockers. So these are also a labeled store. This is the label, and this is the storage locations. Similar sort of thing is happening here in a computer. So variables are nothing but labeled storage locations whose values can be manipulated by running programs. So by giving some instructions to the human, also you will be able to manipulate what goes inside this storage locker, right? So similar way we can manipulate what is present in the storage using some code, right? So and in Python you can declare any variables in this way. You just have to give the variable name here. Let's say this is variable name, and this is the value of variable, right? So in this style we declare variables in Python. So yeah, we can definitely declare strings and integers, and we need not actually mention the data type before to the compiler, and it automatically handles for you in the background. So in Python it's mostly like you would be declaring this variable somewhere else, and you would be getting the address or the pointer to that variable. This is how it works most of the times, and with Python it works only this way. And let's go to the next topic, which is dynamic typing. So there are two things, which is one is static typing and dynamic typing, right? So let's quickly see what these two mean. So in dynamic typing, we have a value x equal to 10, and you are asking to print it. So it will definitely print 10, right? And again, you have what you have done here. So you have some storage and you kept 10 inside, and this is the X that is pointing it. So again, what you have done here is you have assigned hello world. So here you have hello world, and you just remove this connection and you just assigned hello world to X. So this is how it works in dynamic typing. Yeah, this is the same illustration we have here. So initially X is pointing to 10, and now that connection has been removed and it is pointing to a string which is called as hello world now. So this is called dynamic typing, wherein you can actually assign a value of integer first to X, then you can very well assign a string to X, right? So this can be done in languages like JavaScript and Python, and other higher level languages which are dynamically typed in the sense you need not declare it prior, right, in which type of variable are you going to use for your program. And there, on the other hand, we have static typing. Static typing is nothing but data type attached when the variable is defined and it is fixed. Later the type can't be changed. So in C, C++, Java, this kind of methodology is followed, and how you write it there, int a equals to 10 or int a basically. So here you are defining the type of the variable as integer before compiling actually. So this is called a static typing. And dynamic typing, data type of variables can be changed, right? So that is the difference between static and dynamic typing. And the next thing that we are going to see here is multiple assignments. So in a language like Python, C++, JavaScript, etc., I think most of the languages would do support this. So what you're doing here is you're assigning 10 to A, B, C all at once. Ideally, how the compiler does it, it assigns to C first, then the C value is assigned to B, and then B's value is assigned to A. Same value can be assigned to multiple values in a single statement, right? So that is how it works. Same value can be assigned to multiple values. Same value can be assigned to multiple values in a single statement, right? That is how it works. And assign multiple values to multiple variables. So you can as well assign 10 to X, 20 to Y, and 30 to Z. This is possible in Python. So you need not write three separate lines for actually describing all this in three different lines, but you can write straight away X, Y, Z equals to 10, 20, and 30, and that would do your job. And for swapping two values, you will write it this way, XY equal to YX, right? So I think this is something which, these are like some note points or observations. And yeah, so how basically C or C++ handles things, and Python handles things, that is being illustrated in this picture. In C++, it's like let's say you have a rented house or your own house. So what you would do, if you want to make any changes to that house, so you will have to do it yourself, right? And let's say, for example, there's a room and it's yours, and 3 is sitting inside that room. Now you want to place 6. So you have to remove 3 and put in 6, right? So basically, if I say just a moment, if I say value equals to 3, and then if I just update value equal to 6, so what is happening in the background is the same in the same room, 3 is being removed and 6 is being replaced with 3 in languages like C and C++. But in languages like Python, what is happening is, when I say value is equals to 3, let's say we have numbers 3, 4, 5, 6, etc. With us. So when I say value is equal to 3, value is pointing to this 3. And when I say value is equals to 6, this 3 is not removed from here. Instead, it stays there only. So what happens instead is the value starts pointing to 6 now, which is a different room. The way you can imagine it is like this points to a different location altogether. That is how things work in Python. And the next part is simple input and output. So how we are gonna take input and output to Python, So to get input from user interactively, we use built-in functions input. So this is the function that we use to get input from the user. So the syntax goes like this: variable to hold value is equals to input of display message, right? So yeah, whatever message you want to display to the user, like enter your name or enter what's your class and all those stuff, and you just have to use an input function which is given to you, and then whatever the user enters will automatically get stored in this. So input function will always return string. This is an important point in Python. So the input function always returns a string, and it's your responsibility to convert it into integer or float point values by using these functions, by explicitly mentioning it as int and float. So yeah, apart from input, so we have another function called output, and this output is generally used to log or display something to the standard output device. And the standard output device is normally a monitor or your laptop screen, etc. Either it can be something else as well. So what are the features that this print function will give you? So it auto converts items into strings. So numeric expressions are evaluated first and then converted into strings, and it inserts spaces between items, default value of separator. So what do I mean by it insert spaces? Like, let's say I have print Python C++. So I hope it should insert a separator called a space in between these two, and that's how it should work mostly. And it also appends a new character at the end of the line unless we give a custom argument. So let's say we have a statement like this: I teach Python for class 12. So default, whenever this statement is executed automatically, and the cursor moves to the next line, and it ends with a slash n, backward slash n. So new character is being inserted, and yeah, if you don't want that new character to be inserted, and you can always define your custom end equals to particular character that you want to insert. Yeah, that can also be done. And after this we have data types, and data types are something which are very common to all the languages. And what all data types we have here in Python: we have numbers, string, list, tuple, and dictionary. So numbers, what numbers would contain? Basically integers and float point numbers. And we also have complex numbers in Python, and booleans is a sub part of integers. So data types for numbers are generally integers, float point numbers, complex numbers, right? And integer is nothing but normal integer representation of whole numbers, big or small. Basically integers are signed integers in Python. They can be either positive or negative, right? And next part is boolean. So subtype of plain integers represent truth or false. So the truth or falsy values would come under boolean, and they would also be equivalent to 1 or 0. The next thing that we have is floating point numbers. They are used to represent machine level double precision for floating point numbers, 15-digit precision. And the range actually depends on the underlying machine architecture. It varies based on machine to machine. And this is how we represent complex numbers, and we are very well familiar with this stuff, which is z equals to a plus ib or bj, whatever. This is square root of -1 j, right? And so this is how Python stores numbers. And the next data type that we are going to see is strings. So in strings, all strings in Python are sequences of pure Unicode characters. So what is Unicode character here? So Unicode is a system designed to represent every character from every language, irrespective of whatever language you have, be it Arabic, French, or any Indian language. So we have a Unicode character we have a Unicode encoding for every character. They can also hold numbers, letters, special characters, and emojis. So Python string is a sequence of character, and each character can be accessed by index, right? So if you want to access any particular character, you just have to access it through the index. So the next topic, the next data types, we are going through the data types in Python. So the third one we have list, then tuple, then dictionary, right? So let's quickly understand what list means. A list is nothing but a group of comma separated values of any data type between the square brackets. So this is a group of comma separated values. So the first value you could see is a string, then there is an integer, then there is a character or a string you could say. Then we have a float point value. So all are different, but still they can be they can be basically collected under one data type called list, right? So and the one more thing that you have to notice is that lists are mutable in Python, and there is something called mutable and immutable. So what mutable essentially means that is this values can be changed, right? And there is one more data type called tuple. Tuple represents a group of comma separated values of any data type within the parenthesis, and tuples are not mutable, meaning once declared you can't change this, alter these values, right? So that is how it is. And the last data type that we have here is dictionary. So what is dictionary? Dictionary is nothing but an ordered set of it is not ordered, and it is a set of comma separated key value pairs. It is a comma separated key value pairs with the condition that no two keys should be same. So these are the keys, and no two keys should be same, they should be different, right? So that is the only condition that we have, and these are enclosed within full argbases. So the core data types in Python, we have numbers, we have none or none, we have a special data type, this is, and this we have sequence, and we have also mapping. So under numbers we have integer, floating point, boolean, and under sequence of characters we have string, tuple, and list, and in mappings we have dictionary, right? And the next topic is mutable and immutable, just what we have discussed now. So immutable, that is simply means that it can never change the value in place, right? So what are the data types that are immutable? Integers are immutable, floats are immutable, boolean, string, and tuples are immutable. So pretty much many data structures in Python are immutable. So once you declare, it is there forever, and you just simply change the pointer to a different value so that you will update the variable or integer or anything. So how do you change the reassign the values if all they are immutable? Like a is equals to 5 you have given, and then you are telling a equal to Python, etc. So the answer is variable names are stored as references to the value object. So each time we change the value, the variable's memory address change. What that means is, like, let's say initially we have declared p equals to 5, q equal to p, and r equal to 5. So see, we have declared p equal to 5, right? So p is pointing to 5, this much is done, and then we said q is equals to p. So then since q is equals to p, then q will also point to 5, right? Then again we said r equal to 5, so all three are pointing to 5 itself, right? Then we made these changes that p is equals to 6, so this would be mapped here now. That is what is happening here. And next I said q equal to 8, so q would map here, and then finally r is equals to p, so r would also point to whatever the value p is pointing. So we can clearly see that only these pointers are being changed all the time. So whenever you write p is equals to 5, so whenever you write something like p equal to 5, initially memory is pulled from the computer, and the variable is stored in the computer, and this reference is being established, right? So that is how it works in Python. So that is how we are able to change the values despite them being immutable. So immutable means this 5 can't be changed in place, and you can't write 6 here. That is the thing. So that can be done in C++, but because Python is an abstracted language, so we don't have that. We don't have to bother about that, and Python does it for us automatically. And so these all are immutable data types, right? Integer, float, booleans, strings, tuples, etc. So what are the immutable data types that we have in Python? So we only have three data types which are mutable in Python. First one is list, second one is dictionary, and third one is set, right? So what is actually mutable? Same memory address, new values can be stored as and when you want. So it's the same. For example, this is the yeah. So this is the same memory address. Let's say we have something here, and we are not changing or we are not creating anything new like this. We are changing everything in place. Let's say first we have 3 here, we just change it to 4, then we changed it to 5. So what it essentially saying is same memory address, new values can be stored as and when you want, right? Mutable is change in place. So this means that you are not creating more, occupying more and more memory. You are just making changes in place, which is a good thing. So the data types that allows you to do all these things in Python is list, dictionary, and set. So all these three data types are mutable in Python, meaning you can alter them whenever you like, right? So after that we have expressions, and any valid combination of operators, literals, and variables are known as expressions. So we have arithmetic expressions like 2 plus 5 power 3. We have relational expression, which is comparison. We have logical expressions, and we have string expressions. This is basically string concatenation. This plus here refers to the concatenation of strings, and it will just add these two. So these are the expressions that we have in Python. And after that, let's see how Python does evaluate arithmetic expressions, right? So let's say we have x divided by y, but x is of type integer and y is of type float. So definitely the division can't happen with two different data types, right? So Python, what it does is it kind of converts one data type in the lower data type into higher data type, and then does the calculation. So both are converted to the higher data type, higher meaning which can store more size, etc., and evaluate based on the rules. And also we have this concept called operator precedence, and this is something like Bodmer's rule, etc., which we have studied in mathematics, which stands for bracket of division, multiplication, addition, and subtraction. So here also similarly we have the parenthesis on high priority, then exponentiation, we have later bitwise operators, unary operators. And the one thing to observe here is like multiplication, division, and remainder, and floor division, etc., they all stand at the same level, right? This, you don't have a preference of division over multiplication, etc., in Python or C++. So that is something which has to be noticed. And yeah, so this is the order of the precedence of operators that we can say. And the next part is evaluating relation expressions. So all relation expressions yield Boolean values. So yeah, relation expression is nothing but basically x greater than y or something of that sort, comparison and all. So they always give you a Boolean values. Logical expressions are based on based on these rules. The logical expressions are evaluated. And next is like typecasting. This is a concept wherein you can declare a variable as an integer, but you can cast it as a float point value, or vice versa. You can declare it as a float point and then you can convert it to integer as well. So this is called typecasting. And the last concept in basic vocabulary or grammar of Python is the math library functions. And these all functions, just a moment. So yeah, so these all functions are provided in the math library in Python. So all the familiar sine, cos, power, logarithm functions, floor, absolute, exponentiation, square root, ceiling, tan, degree, radius, modulus, etc. are present. So you can directly use them whenever you need in your logic building, right? And next we'll quickly go through statement flow control. So after going through the basic data types and other concepts in Python, now let's look into a topic called statement flow control. So in any programming language, statements may be executed sequentially or selectively or iteratively. What does that mean now? So sequentially means simply line by line, or selectively means skipping some statements and executing others, or iteratively is like continuously. So how, when and why are we gonna do that? So let's quickly understand that. So conditional statement is what is a conditional statement? It's a statement that is executed based on a condition, right? And loop statement is executed repeatedly until the end condition comes to that statement. So, and we have some jargon here, so let's quickly go through that. So we have something called as a compound statement, right? We have something called as a compound statement, simple statement, and an empty statement. So what is a compound statement? Compound statement is a group of statements that are executed as a unit. So either all are executed or nothing is executed, or something like that sort you can think. So what is a compound statement? Let's quickly go through an example. So this is a compound statement header, and this is the intent body containing simple or compound statements. So let's look at a very familiar if example. So we have a condition here that if number 2 is less than number 1, assign number 2 into number 2, basically square of the number into t and increment t by 10. So this complete logic is being executed based on this condition, and after executing this block we are printing number 2, number 1 and the variable. So this is how a compound statement looks like. So in the compound statement we have a condition and we have logic to execute, and then we'll print. This is not part of compound statement, but basically this much you can call it as a compound statement, right? And after that we have a simple statement, and simple statement is nothing but any single executable statement is a simple statement in Python. So what do you mean by that? So let's take this thing. So what it is doing is like it is incrementing the value of t by 10. So is this a simple statement? It should be, right? So because why? Because it is just any single executable statement is a simple statement. So this can be executed, and this is called as a simple statement. The third type of statement that we have is an empty statement, and it's simple. Empty statement is just this line in Python. If you write pass in any part of your code, it will just do nothing from there, and it will just pass control from there. So these are the three type of statements that we have in Python: compound statement, simple statement, and empty statement. After statements, let's again go through some conditionals. So what is a conditional? By the name only, it's intuitive that it's based on some conditions. So conditionals and these sort of stuff we see in every programming language. And what happens here is, like, if there is a particular condition, so execute these statements, right? Otherwise execute these statements. So this is a plain if statement, or this much is a plain if statement, and if you add a else block to it, then it will become a if else statement. And we have something called as elif in Python, which is simply like else if in other languages. So we can use this sort of syntax as well. So if a particular condition, then if doesn't work, then else if check this condition, and finally do this if nothing works. So this is kind of if conditionals, and we can have a nested if as well in our statement. So if this occurs, then do this, then this occurs, then go to the third thing, something of that sort. And last we have storing conditionals. So let's say we have a task in hand that we have the values of b comma c as 2 comma 3. So if we have to check if they are really equal to 2 comma 3, so we have to write it if b equals to 2, then again check for equality of c with 3. But a better and neat way of doing this thing is like we can define all equals to a equal to 1 and b equal to 2 and c equal to 3. So all these things are defined in a single statement with all, and if you write it this way, it checks for all these things, and you can directly return true from here. And after the conditional statements, which are else and if, we have something called a looping statement. Generally, when do you use loop? Loops in any language are used for a repetitive task. So what loops do we have? We have for loop, we have while loop, right? So these are the two loops that are available for us in Python. So general for loop looks like this. For a variable in sequence, you just write the statements that you want to repeat. So the best example is, for element in this list, print element plus 2, which will print you 12, 17, 22 and 27, I guess. Yeah. So basically, for element, for variable in sequence, whatever sequence it is, you will just write the logic. And second loop that you have is a range based loop. The range based loop is nothing but similar to the previous loop, but it works in a little different way. So here you write again the variable here, and in the range of, you specify the range, right? And you are asking to print the value. So what this range does is, like just like the previous example, it generates a list first, which is in the specified range. So it starts with 3 and goes till 17, with this last value is not included. And again it would do the previous operation, and it will loop through the range and print the values for us. So in the range function has 3 parameters: start, stop, and step. If you don't specify anything, if you don't specify the third parameter here, so the step is defaultly taken as 1. And if you just write something like this called range of 7, so you only have mentioned one variable, right? So it is the interpreter interprets this as a stop variable, and it automatically sets start equal to 0, right? So this is how things work in the background. And that is how you can work with your for loop in Python. And next we have while loop. So in C, C++, Python, every language, we have the similar syntax: while logical expression. While logical expression in the sense, while I less than 5, or print I, something of that sort, so, right? So we'll be having some similar syntax in all the languages. You just have a semicolon at the end. So this is a while statement, and these are loops, right? For and while. So we also have something called jump statements in Python, which are break and continue, and in most languages you will find them. Break terminates the loop in which it lies. So let's say you have a for loop here, and something is going on, right? In Python, if I have to write, so it's like for I in range 0 to 5 and semicolon. Let's say something is going on here, and you have written break if something happens, and finally there is some lines of code later as well. But whenever your interpreter encounters break, so it terminates the loop in which it lies. So it just goes back out of this loop and continues its execution from the loop. So this part is done whenever it is encountered this break statement. And let's say we don't have break here, instead we have a statement called continue. So what happens in case of continue is, like, these all instructions are definitely executed, and the instructions that are present after continue statement, they are skipped, and the control again goes back to the start, and these conditions would be checked, right? So continue skips the rest of the statements in loop after it. And if we have to see more on loops, what else we have? So in Python we have else statement. Generally we don't have this in other languages, but Python we have an optional else clause. And how it works is, like, after the else executes when the loop terminates normally. So what do you mean by loop terminating normally? The test condition in the while loop becomes false, right? So while loop, at one point of time, definitely this test condition should become false, otherwise it would go into an infinite loop. So whenever this becomes false, it's a normal failure, right? Normal, not a failure, it's termination. So then the control comes to else. Otherwise, after execution of for loop, the execution will definitely come to the else statement, right? In that case also, this is executed. The last topic in this is we have nested loops, and nested loops are nothing but loops in loops, and whenever we have to print something of this sort, let's say we need to print some pattern, okay, and we need to like print some 2D matrices and all, right? So we will definitely need one loop for iterating through rows and another loop for iterating through columns, or however it works in your code, right? So nested loops are nothing but loops within loops. So every time you encounter such thing, first the inner loop action would be completed, and again for the next variable, again this loop is invoked, and all these tasks are completed, and the control goes back to the outer loop, and it executes that way until these two ranges are completely covered. So I think this would sum up to the basics of Python and all the jargons that are mentioned in this chapter. So what all have we covered? Initially, we have started with tokens in Python. Tokens are nothing but keywords, identifiers, literals, operators. Basically, everything that you see in the Python code are known as tokens. So then we have quickly gone through what all keywords, operators, and all these things are. Then we have seen punctuations, the bare bones of Python program, and how variables are assigned and all this stuff. Then what is the difference between static and dynamic typing? What are the static type languages, etc., and storage, how that works in Python. And the next part that we have gone through is like what are the data types that are present in Python,